Traffic Impact Assessment, presented by Mikim Platides, Wilner Saldia, Riangel Rabanes, and Michael Pion.
Hi everyone, this is Maria Mikim L. Platides, and I will discuss to you the introduction of Traffic Impact Assessment. What is Traffic Impact Assessment? Traffic Impact Assessment, or TIA, is a technical analysis of problems, safety issues relating to a specific development. So, Traffic Impact Assessment, or TIA, uses patterns to identify any improvement and provide solution to a specific problem. In other words, Traffic Impact Assessment, or TIA, plays an important study to give people an adequate access and lessen the traffic congestion. Well, this is the main problem that has arisen of extensive private vehicle use. Traffic Impact Assessment acts as a countermeasures for potential negative impacts, are responsible in predicting or addressing the potential transportation and traffic problems that will occur from the development. Now, let's proceed to the objectives of Traffic Impact Assessment. First, Traffic Impact Assessment is to identify whether a particular development project will have an impact on the safety and efficiency of adjacent roads. And the last objectives is to make it easier way to investigate and develop traffic management plans in assessing to minimize traffic congestion. Next, let's see the importance of TIA. TIA, or Traffic Impact Assessment, is very important in order to predict or estimate the additional traffic that is associated with the new progress and serve as to determine the improvement that are necessary to achieve in order to our safety and peace. TIA is important to conduct in order to assist in land use decision making. And how this to make it happen? First, let's how to identify all potential problems and allowing the community to assess impact of a proposed development. Due to the traffic congestion that has been increasing in much of the world, traffic impact assessment is conducted in order to help us for our safety and reduce the negative impact created by the developments, and by ensuring that the transportation network can accommodate the progress.
Why do we need traffic impact assessment? A traffic impact assessment will look at what possible outcomes a specific action can have and how to minimize or prevent any negative outcomes. It means the traffic impact assessment is responsible for maintaining safety and seeking a variety of solutions to a specific problem that might be encountered on the road. Benefits of traffic impact assessment. Traffic impact assessment provides information on the projected traffic expected from a proposed development and evaluates the impact of proposed development on the roadways in the immediate proximity of the proposed development. It uses to help evaluate whether the development is appropriate for a site and what type of transportation improvement may be necessary in order to maintain a satisfactory level of service. So here's the process for the application for proposal development. Usually, traffic impact assessment activities start with the developer. If the developer wants to develop a plan, then she or he will consult with the engineer or architect to design the development and submit it to the local authorities. And then the local authorities will instruct the traffic impact assessment study. Then the development will appoint the transportation engineer and discuss the scope of the study. Then they will proceed with the requirement for a traffic impact assessment. So here's the document required for the submission of traffic impact assessment. We have current status of transportation, development details, methods used to estimate traffic generation, the traffic generation summary table, traffic distribution across the area and assignment assumptions and associated traffic volume figures, traffic safety risk assessment, pedestrian and cyclist impact assessment, intersection assessment inputs, a brief account of proposed construction work as part of the development.
Hi everyone, my name is Wilner Saldia and I'm going to present the traffic stream parameters. The traffic stream parameters includes a combination of driver and vehicle behavior. The driver or the human behavior being non-uniform, traffic stream is also non-uniform in the nature. It is influenced not only by the individual characteristic of both vehicles and human, but also the way of the group of such units interacts with each other. Traffic stream parameters. The three main variables or parameters for traffic main analysis of highway performance are flow, speed, and density. So the first main variable is flow. So flow is the number of vehicles that pass a point on the roadway during specific time interval. So for finding Q, mo na siyang equation ng gigamit. Q is equal to N over T, where Q is equal to traffic flow in vehicles per unit time, and N is equal to number of vehicles passing some designated roadway point during time, and T is equal to duration of time interval. The next variable is speed. Average traffic speed is defined in two ways. Time mean speed is the average speed of vehicles passing a point on a roadway over specified time. Example niya kay katong radar gun. So, ang equation sa speed kay U is equal to submission of W over N. Ano siya? So, next is the density. So, the density is the number of vehicles occupying a given length of roadway at some specified time. So, ano siyang equation? K is equal to N over L, where K is equal to traffic density in vehicles per unit distance, and N is equal to the number of vehicles occupying some length of roadway at some specified time, and L is equal to the length of roadway. Variable relationship. A sample identity provides the basic relationship between traffic flow, speed, and density. So, muna siya ang equation. Q is equal to U times K, where Q is equal to flow, typically in units of vehicles per hour. U is equal to speed, or the space mean speed, typically in units of miles per hour. And last is K is equal to density, typically in units of vehicles per miles or vehicles per kilometers.
So let's proceed to the basic traffic stream models. So traffic is the study of interaction between vehicles, drivers, and infrastructure like highways, signage, and traffic control device. So we have here the models that help us understand the interaction between vehicles, drivers, and infrastructure. So we have here first the speed density model. The speed density relationship can provide a solid foundation for traffic flow analysis and efficient traffic management. Focusing on the relationship between speed and density is the most intuitive starting point for building a consistent universal traffic model. To begin, consider a stretch of highway with only one vehicle on it. The density will be low under this condition, and the driver will be able to travel freely at a pace near to the highway design speed. So imagine no, kanang usara ka kuan kasakyanan na ni dagan sa highway. So understandable na mas kusog yun ang dagan niya and mas dali siya mabot along to the highway design speed. Density will be low under this condition, and the driver will be able to travel freely at the pace near to the highway design speed because vehicle speed is unaffected by the presence of other vehicles. This speed is referred to as the free flow speed. So otherwise, as more vehicle use section of highway, the density increases and the average operating speed of vehicles decreases due to the other vehicles' free flow maneuvers. So we have here a figure that shows the representation of the speed-density relationship that provides basic insights into the relationship among traffic flow. And then we have here the flow density model. The resulting flow density curves are concave in the whole range of feasible values for the parameters. So the maximum, so we have to understand that in the flow density model, the maximum flow rate represents the highest rate of traffic flow that the highway is capable of handling. This is referred to as the traffic flow at capacity, or simply the capacity of the roadway. And then the third one is the speed flow model. The new HCM 2010 proposes in Chapter 11 two-stage curves to represent the speed flow diagram for non-congested flow on freeways where constant speeds are postulated over a rather wide range of volumes. The division of the traffic flow in two parts plus the congested condition is a rather pragmatic approach. So the figure shows that the speed flow model defined by this equation gives a parabolic function. It shows that two speeds are possible for flows up to the highway's capacity. So it is desirable for any given flow to keep it average space mean speed on the upper portion of the speed flow curve. The last one, we have here the models of, we have here the Poisson model. The generalized semi-Poisson model of traffic flow is postulated. Its implication in terms of headway distribution outlined and its properties discussed briefly in relation to other models of traffic flow. Limitations of the Poisson model. Poisson regression may not perform well in situations where the conditional variance is greater than the conditional mean, phenomenon known as over-dispersion. Second, in situations where a large proportion patients are never hospitalized or have a zero count, so the data do not fit Poisson distribution model. So Poisson distribution model simply gives probability of an event happening a certain number of times within given interval of time or space.
The team is now open for questions, clarification, and suggestions. Thanks for watching.